All right, we're looking at 7.1, zero and negative exponents. We'll look at first a couple rules of exponents out of 5 of them. So looking at this pattern down here, 2 to the third, we call the 2 the base. We call the 3 the exponent. And the way these work is 2 to the third means 2 times 2 times 2, which would be 8. 2 to the second would be 2 times 2, which is 4. 2 to the first would just be a single 2. Coming over here to 2 to the 0, let's do 2 to the 0 next. Notice the pattern here. As I go from 8 to 4, and then 4 to 2, I'm dividing by 2 each time. So as my exponent goes down from 3 to 2 to 1, I'm dividing by 2 each time. So I would expect to go from 8 to 4 to 2, and then 2 to the 0 is going to be half of what 2 to the 1 was. Half of 2 is 1. And so 2 to the 0 we discover is 1. 2 to the negative 1 would be half of 1, which is 1 half.
Office. Grace McDonald and Emma Pizzuti, please come to the main office.
Then 2 to the negative 2 would be 1 half of the previous one, or 1/4. And then 2 to the negative 3 would be half of 1/4, which is 1/8. Another way to think of 2 to the negative 3 is it's the same as 1 over 2 to the positive third power, or 1 over 2 times 2 times 2. And on the bottom, the 2 times 2 times 2 gives us the 8. 2 to the negative 2 is the same as 1 over 2 to the positive second power, or 1 over 2 times 2, which is 1/4. And 2 to the negative 1 is 1 over 2 to the positive 1 power, or 1/2. This pattern that you see with the exponents will work no matter what the base is, unless it's 0. And you just continue to divide as you go down in powers. And so 2 to the 0 is 1. As a matter of fact, we discover that every non-zero number raised to the power of 0 is 1. So 73 to the 0 would also be 1. Now the key, one of the key components of this definition is that it's every non-zero number raised to the power of 0 is 1. This 0 to the 0 is not 1 because you cannot divide by 0. If you were to use this same pattern and keep going down, each time you go down by a power, you would divide by 0. Well, we can't divide by 0. It's not defined under the rules of multiplication. So 0 to the 0 is what we call indeterminate form, or you could say it's undefined. We'll also be looking at negative exponents here. We saw that when you had 2 to the negative 3, we moved the 2 to the negative 3 to the bottom of the fraction and made the power positive. So when you see a negative exponent, it tells you to switch the location of that base and make the exponent positive. So we'll take some combinations of these today. 9 to the negative 2 would be the same as 1 over 9 to the positive second power, or 1 over 81. Not 18, but 81. And 7 to the negative 1 would be 1 over 7 to the positive first power, or 1/7. Works on variable expressions as long as x is non-zero. This would be 1 over x to the third. 2 to the negative fourth would be 1 over 2 to the fourth, or 1 over 16. 2 to the fourth is 16. On your calculator, there's a little button that looks like this, and you can type in 2 to the fourth power, like that. Negative 4.567 to the 0, because that's a non-zero number taken to a 0 power, it's equal to 1. Down on the bottom here, go ahead and try those. You can pause the video, try them, and then check your answers. I'm going to go ahead and do them right now. All right, now we're going to simplify some expressions that have numbers, letters involved in them. Key to this is to understand that the power, if you don't see parentheses around, for example, no parentheses around the 5a cubed b, that negative 2 power is only applying to b. If I did have parentheses around it, as I've drawn here, the negative 2 power would apply to each number and each letter that you see in parentheses here. So in this case, I like to draw a fraction bar, identify the power on the 5. There's an unwritten 1. The 1 is positive, so the 5 would stay on the top of the fraction. A has a power of 3, which is positive. It would also stay on the top, and then the b to the negative 2, because of the negative power, would move to the bottom and become positive. Now the x to the negative 5 in this case is on the bottom. We're going to move it to the top of the fraction and make it positive. So if you have a negative power in the denominator of a fraction, you'll move it to the top and make it positive. Let's try some of these down here. Go ahead and pause the video and try them on your own, and then you can check with my solution. You may also be asked to simplify and then evaluate an exponential expression. In this case, I would simplify first. 3 has a power of 1 on it. That's positive. That would stay in the top of the fraction. S has a power of 3. That's positive. It would stay in the top. The t has a power of negative 2. I would move that to the bottom and make it a positive power. Then go ahead and plug in the values, 2 for s and negative 3 for t. So we've got 3 times 8. Negative 3 squared would be the same as negative 3 times negative 3, which is equal to 9, positive 9. This is 24 over 9. You may want to cancel even here or here to get 8/3. So go ahead and try these. Remember, simplify first, then plug in. You'll notice on this first one, if I take w to the 0 is 1, move the n to the negative 4 down and make it n to the positive 4. Now I don't even need to plug in the 5 for w. I just plug in the negative 2 for n. Because of that even power, I will have a positive 16 on the bottom. The second one is an example of one you may want to type it into your calculator using the little arrow button, 5 to the 6th power. 5 to the 6th power is 15,625. There it is. That's using negative and 0 powers.